The last lecture considering pulse echo instrumentation is displays. We'll talk about how the picture gets onto the screen and other ways we can archive our images. So we're finally rounding out the whole process of our images being displayed on our screens. Started with the pulsar, got all the way through. We've completed memory now, and now all that information that the memory has processed has been stored and now needs to get onto the display screen. So the information returning from the body goes to the transducer and then through the receiver and the memory into the display. Well, the information coming from the transducer actually comes back in an analog form. We learned in the last lecture that the memory is a digital scan converter or digital memory, so we need digital information to store in there. So how do we get there? Well, from the transducer, the information must go through the A to D converter, which is the analog to digital converter. And now that information can go into the memory to be processed. Older systems have analog displays. And those are any systems that have cathode ray tube type displays, or like those old TVs with the big back. So from the memory, we must travel through another digital to analog converter, and then that information is ready to be displayed on the analog screen. Modern systems, however, have a digital screen, like the two Philips in the upstairs lab and the Philips in the downstairs lab. Those all have digital screens. So now that fourth step where the digital analog converter has to happen no longer needs to happen, and the information from the memory, the digital memory, can go straight to the digital screen. So it is technically a 5-step process if we're using an older system. We're doing transducer to analog to digital converter to the memory to the digital to analog converter to the display. And again, in newer systems, it's only a 4-step process: transducer, A to D converter, memory, and then straight to the display. We consider the display to be a non-permanent type of recording and archiving system. So we can see the information that the ultrasound machine has been processing now. So the display can either be a bistable, which is black or white, or we can have grayscale displays. Most modern equipment now is a grayscale display. Another function of the grayscale displays is that on the actual monitor, you can have 2 controls on there, one being contrast and one being brightness. If you've ever used your menu button on your TV, I'm sure you've seen those 2 options to change how you prefer how that whole screen looks. That has nothing to do with the ultrasounds that are coming back. It has everything to do with what is actually being displayed on the screen. So we can adjust the contrast and the brightness of our display independent of anything going on with our sound waves. So that is a non-permanent form of recording. There are multiple permanent ways to record the information that we get, one being our PACS system onto paper, magnetic media, which includes like VHS tapes, chemical mediated photographs, which are old school X-ray type films, and then optical media, which is what we're probably most common with or most familiar with, being CDs, DVDs, and USB drives. So it's important for you to know what the PACS and DICOM stand for. PACS and DICOM are terms that you'll hear often in the hospital and clinic setting. The PACS system is where all of our images are typically sent to, so our radiologist can view it, and so we can view our pictures on a computer away from the actual ultrasound system. DICOM then is the information that is embedded into the picture and is a specific formatting of the picture. So make sure you know the difference between the two and how they apply into our clinical setting. So PACS stands for Picture, Archiving, and Communication System. Know that. And this is how the images and other medical information are going to be digitized and then stored on a large computer network. Most hospitals and clinics will have some sort of PACS administrator. They are responsible for making sure all of this runs very smoothly. There are times that the PACS system goes down and it causes quite the headache because we're no longer connected in between departments, and the radiologist can't see things, and it makes it very difficult to operate a radiology department. So the PACS for the radiology department is kind of the lifeline of it. So the advantages of the PACS system then is that there is instant access to archives. So not only can I see the pictures that I just took, but I can see pictures from however long ago the PACS system stores. Often it's multiple years worth of images. We also get no degradation of data over the time. If you were to save pictures on like paper or on films, they can start to get smudged, or they can start to fade, and they're just not as stable as they are in the PACS system. And then the PACS system also promotes accessibility in remote sites. So you can have a radiologist sitting up in Duluth reading pictures for somebody down in the Twin Cities. It just offers much more portability and accessibility in between hospitals and clinics. DICOM then is the type of format that our pictures get sent to PACS in. So DICOM stands for Digital Imaging and Computers in Medicine. DICOM has a set of rules that it must follow, and it is very specific to medical imaging. And with those rules, that means that all the medical imaging done at one place should be displayed or be able to be viewed at another place because of following those rules. So all medical devices should work with DICOM for formatted imaging. This is going to allow for better communication between systems. It also adds some security within the pictures as well. Since this was a relatively short video, your video guide and questions will be one and the same. So number 1, what is the 5-step process for getting information from the transducer to the display? Number 2, what is PACS? Define it and say what PACS stands for. And number 3, what is DICOM? Again, define and say what DICOM stands for.